Okay, now we are going to learn how to resolve the weight component on an inclined plane. So we have this angle theta here, mass m, and of course we're going to have weight acting downwards. So we need to resolve anything that's not in the I direction or j direction. I direction here is parallel to the ramp, the inclined plane, and j direction is perpendicular to the inclined plane. And we can clearly see weight is not acting in either of those directions. So weight can be resolved into two components. So this is weight. So we've got this component and then that component. Now we can say that this angle is 90. So this would be 90 minus theta. And this whole thing is 90 because we're finding the component perpendicular to the ramp. So this angle, the one I'm highlighting, and this angle, the one I'm doing in orange, they must add up to 90. So that means this angle is then also equal to theta, because 90 minus theta plus theta will add up to 90, which should be the case. So now we are going to label our triangle. That's the opposite, that's the adjacent, and this is our hypotenuse. So cos theta equals adjacent over hypotenuse, therefore adjacent equals h cos theta. So h is our weight w, so that means the adjacent side is equal to w cos theta. So I'm going to write here w cos theta. So the component of the weight perpendicular to the surface acting downwards is w cos theta. Have a look at the opposite now. So sine theta equals opposite over hypotenuse. So opposite equals h sine theta. Hypotenuse is w, so the opposite component is equal to w sine theta. So I'm going to write w sine theta here. And you've resolved weight into two components. So in any inclined plane problem, the first thing you do is, when you have a mass, you know that the weight acts vertically downwards. The component of the weight that balances the normal, because normal we know acts 90 degrees to the surface. So the component of the weight that is balancing the normal is w cos theta. And this opposite component here, which you can draw here, but as you know, I can move a vector parallel to itself. So instead of drawing this here, I'm going to draw it here. It is w sine theta. So w sine theta is the component of the weight that is responsible for pushing or dragging the mass down the ramp, and w cos theta is the component of the weight that's balancing the normal reaction in this case. So that's what you do. So I'm going to go through the forces on an object on an inclined plane one more time. So on an inclined plane, when you see a mass, normal acts perpendicular to the surface, upwards. Weight acts vertically downwards. Then you resolve your weight into two components. The one that drags the object down is w sine theta, and one that is opposite to the normal here in this direction is w cos theta. And that is how you resolve forces of weight on an inclined plane.